Now as we move into 7.2, a lot is going to be similar. Now we're going to be finding a confidence interval for the mean. And as we go to find the confidence interval for the mean, it's going to be pretty much the same. We're going to take our best guess, which in this case is x bar. We're familiar with that being the sample mean, which is the best that we can do, but we're going to recognize that it has some error. So it's going to be very similar to what we did in the first part of 7.1, and that is to take our best guess for the situation, in this case x bar, and add and subtract some error. The x bar will be flat out given to us, just like the p hat was in many instances, but we're going to have to go and calculate the error. And so the error formula, it looks like this. It's a little bit different. We've never seen this t before. T alpha over 2, and then it's s over the square root of n. That's the formula for the error that we're going to be using. And so the only thing that's different about this really is the chart that we have to go up. S will be given, and n will be given in the problem. So if we can learn together how to get this t alpha over 2, then we'll be set. So t alpha over 2 is found by using two pieces of information. In order to determine it, I'll need to know a sample size, and I'll also need to know an area, right? Or apologize, let me restate that. And not as area, but how we're going to get that area is a confidence level. So those are the two pieces of information that we need to pull out of the problem to help us find t alpha over 2. So when we're going to go to that chart, the chart's going to talk about something called degrees of freedom. Degrees of freedom will show us which row to go to, and degrees of freedom is very simple. It's the sample size minus 1, always. When we do this one variable statistics, it's n minus 1. And so if our sample size was maybe something like 30, our degree of freedom would simply be 29. So if n is 30, the degree of freedom is 29. It's that easy, and that will tell us where to go. If that row is not there, then we go to the closest row. The confidence level will help us out as well. So the t-distribution actually looks just like the normal distribution. It's described pretty well in the PowerPoint slide, so I don't want to redo that. But just picture t as a bell-shaped distribution with the mean right in the middle. Because of that, when we do let's say we're doing a 99% confidence interval, we're still sandwiching 99% in the middle and splitting up the 0.5% into each one of the tails, or splitting the 1% as a 0.5% in each one of the tails. So it's still going to look the same. So let's keep that in mind as we go look at our charts. So let me bring up the charts, and I'm going to come to this chart thing that you have. Now they've ran out of covers of the textbook, so when you go to find the t distribution, it'll be in the middle of the appendix there. So here's the t distribution, and as you can see, it relates to degrees of freedom, and then also across the top are the area in two tails. So let me remind you of what we had. We were looking possibly at apologize, let me get a pen here. We were looking at maybe a 99% confidence interval. If you have a 99% confidence interval, then the area in the two tails combined, so notice it says area in one tail, area in two tails. Confidence intervals always have two tails because you're sandwiching the 99% in the middle. And so what we're recognizing is that we have 1% split up into two tails. It's got to go into both of those tails. So the column that we're going to be in, because of a 99% confidence interval, is going to be this first one right here. So notice it has 1% split up into two tails, but also 0.005 in each one of the tails. So that's the column that we're going to go to. I think I made up the fact that our n was 30, and so our degree of freedom then would be 29. So if your n's 30, your degree of freedom would be 29, and we'd simply go down here to the 29th row and grab the 2.756. 2.756 would be the T alpha over 2 value. So T alpha over 2 would be 2.756 if I had a sample size of 30 and a desired 99% confidence interval. So that's the number that I would use in my problem. You'll see that demonstrated as we look at an example together or as you look at the examples in the book. But you simply use the chart to narrow into the values. While I have you here, remember that this first column represents 99%. Take a look at what it limits out to. It's getting bigger and bigger and bigger, and it limiting out to really close to 2.575, which is what it would be for a z value. So what the t distribution is doing is it's respecting small sample sizes and morphing that bell-shaped curve right into a z as you look at larger and larger values. You can see that for 95% it limits out to 1.96, and for 90% it limits out to 1.645. So as we look across the top, hopefully degrees of freedom is easy. It's just the sample size minus 1. If you're looking carefully across the top and we just look at the area and two tails, then this first column must be for 99% since there's 1% split up into two tails. The second column must be for 98% because there's 2% split up into two tails. The third column must be for 95% because there's 5% split up into two tails. The fourth column must be for 90% because there's 10% split up to two tails. And then the last column is 80%. So we can't ask you anything other than a 99%, 98%, 95%, 90%, or 80% confidence when we're dealing with the confidence interval for the mean. For the proportion we could because the z-table is more robust, but for the t-table it's a one-use chart, and so it's trying to give you exactly what you need very easily, and that is a t alpha over 2 value. So watch this be explained in another example, but that's your general overview to supplement what's already there in the book and also in the PowerPoint slides.